I'm going to talk about some stuff that actually happened, and maybe some stuff that didn't, and maybe some stuff that will. Oh no, it's small. I made this big for for my low resolution expectations, and they weren't met. That was me. That's pretty scary. But really, my hero is Ash Williams. And that was how I looked after the Browser Wars 1.0. My hand went bad, so it had to come off. Got better. You know, oh, hell with it. You know, I've had enough of this Chuck Norris guy. Bruce Lee kicked his ass in one movie. I don't know if you know that. Plus, seeing Croc's head photoshopped on has been haunting my dreams in a really bad way. That's a YouTube quote. Somebody commented on one of these. So I met John McCarthy, the creator of Lisp, in 1977. And he gave me some advice.
When thou retrievest the book from its cradle, you must recite the words klaatu, barada, nikto.
Klaatu, barada, nikto. Okay.
Well, repeat them.
Klaatu, barada, nikto.
Again!
I got it! I know your damn words, all right? Ooh, wait a minute. The words. Right. Say the words. Klaatu, barada, necktie, nectar, nickel. Noodle. It's an N-word. It's definitely an N-word. It's definitely an N-word. Klaatu, barada. Okay, then. That's it. Hey, wait a minute. Everything's cool. I said the word. I did.
Something's amiss.
So Croc has been saying that ever since he took over from McCarthy. And And I said I'm wrong. I talk a lot about being in a hurry, which was very true. I didn't sleep much. I did the prototype for JavaScript in 10 days. But really, I'd already read SICP and I'd studied Scheme, and I had no good excuse for some of these things. Maybe it was the sleep deprivation. Maybe I was like Ash, a little bit slow in some ways. But you know, can we recover from this? I think so. Because here's my book. It's very short. And I'd like to say you can use the ++ operator if you want to. So for a long time, there was a concern that evil would triumph. But I think the good news is we actually have a somewhat functional standards body, and that's rare. It's, you know, it's got its little soap operas and stuff going on, but it's not a split committee. It's not a big open war. And there's a lot of agreement, actually, among like Mozilla and, to the extent that I can get them to say anything, Apple and Microsoft, and parts of Google. I think like Microsoft, Google has many opinions. But the ones that are represented on the committee are pretty harmonious. And we're trying to actually prototype and user test what we are drafting before we finalize it. This didn't quite happen with ES5, and that's a disappointment to me, but we're implementing that. It's nearly done, and Apple is, and Microsoft's got an implementation of ES5. They haven't shipped yet. We're going to do better next time. And we're going to iterate, and we're going to leave stuff out that doesn't work or it's too hard. And we actually have a deadline. So like Jamie Zawinski said about Netscape, you know, we believe in quality. We're going to ship the highest quality by, you know, March 31st that we possibly can. So we are both quality and date-driven, and that means there may be cuts, but we will get the good stuff out because there's no reason to wait. So I want to talk about some of this. There will be some code. Some of you may have seen some of this, but it's all online. You can go there to the wiki and read the glorious proposals. We're trying to do open standardization with ECMA, which feeds into ISO and has its own crazy IPR policies. And it's a bit of a struggle, but I think we've kept it pretty open, and we're going to keep going that way. We want to add a few things that are missing in the language. Everybody writes var for things they really want to be constant binding, so we're going to add const. Destructuring, some of you probably know from Firefox's engine, from SpiderMonkey. It's in Rhino, too. It's very popular. I'll show it. Functions that are actually in block scope that work right. Let is the new var. Parameter default values, and something that will drive a stake through arguments. This crazy object that got actually worse during standardization in 1997. And that's the rest parameter and the spread operator. And then something recently promoted to harmony status by the committee is, and I'm not going to talk about it because it's way too complicated, is a system for doing meta-object programming, meta-programming. It's based on some work by an academic named Tom Van Cutsem, who's very smart, and it's what people have been trying to do all these years with no such method, which is a SpiderMonkey extension, or other kinds of catch-alls. And the neat thing about proxies is that they're these empty objects that you can have intercept any operation and do the right thing. So you can make them do whatever they want. This magic ability to intercept operations is something that's hard to graft onto a pre-existing object, a live object, a DOM object. You don't want to mess with that. But if you make a brand new empty object, which is of a certain type, a proxy, then you can do what you want, and you can have it front for the DOM object. And this is actually something we hope IE will use, and other browsers, to level the playing field between the weird territory that ECMA calls host objects, which are these crazy things like alert in the IE DOM, which is not a function, or a lot of the IE nodes, node types and subtypes. We see a future where proxies allow developers to erase the difference between a host object and a built-in object or a user-defined object, and make emulations, make virtualizations that are not leaky abstractions. And so that's harmonious. That's something I'm not going to talk about, though. So const is very straightforward, except for the binding rules. It is not like var, it is like let. If you say const in a block, it's scoped to that block. You can't use it before the initializer has been evaluated and the value assigned to the constant. And you can't write it after that. There's a crazy thing in SpiderMonkey where if you put a const k equals 42 in a loop, you can change it every time. You could set it to the loop variable if you wanted to. And I think we're making some things errors instead of letting them be hopelessly confusing. So there's an example. If you happen to have some pre-existing, like maybe it was a browser property named k, who would do that? If you tried to declare const k, you'd get an error. Destructuring is insanely popular. It's like packing and unpacking in Python. It's sort of the opposite of initializers or object literals, array literals. It's great. It's pretty much syntactic sugar. And it works for object patterns too. There's even a shorthand where if you want to use the same name for the property and for the value, you can just leave out the colon and the right-hand side. And you can use it in all the usual places, arguments, catch clauses, for loops. Functions in block scope. These don't work the same cross-browser. We did something that was supposed to support conditional compilation because it seemed like a good idea. So ours bind their name in the variable object in the current scope, non-block scope, either the function activation or the global object, depending on where control flows. IE, and then everybody who imitated IE does something where they'll just make the last one win. And so since you can't count on a cross-browser, we figured we should change it to be sane. So functions inside blocks are going to be block local. And by the way, some implementations allow the braces to be removed and still have a function as the consequent of an if. Doesn't seem like a good idea. We're not going to allow that. This is one of those cases where if you have disagreement among the browsers, even though there may be web content that's like doing if document.all and then counting on it, we're going to say, let's clean it up. Let's consolidate the semantics around one sane set of rules and not have browsers differing. And again, function always hoist. It's like let rec in Scheme. You can refer early to it, unlike const and let. And if you refer early to var, you get undefined, which is kind of confusing. And that's that. Let is the better var. And people are using this in all of the Mozilla code that they can, all the add-ons, all the Zool code for Firefox and the other apps. And it's just a better world. You can even hope that, I don't know how many people write a for loop, and inside it they have a closure, and the closure uses the loop variable. And then at the end, they're very disappointed when all those closures that were formed, that were stored in an array, get called, and they all report the same value for the loop variable, the loop bound. Because we aren't Scheme, we have closures over environment objects, not over bindings. But with let, we have something new under the sun. And this is another example where you can take an extension and use it to fix some semantics. So if you use a let instead of a var, then we can, at least for the for in loop, give you a fresh binding every iteration. If you capture it in the closure, you get that particular let binding. It's truly lexical in the sense that the Scheme people use. Parameter default values are just kind of obvious and good. They get rid of this idiom that everybody sees. This causes people to say, let's have double or equals. You know, Ruby has it. Well, Ruby's is a little different. It's kind of like unless. If we did it, it would be like double or equals expanded, like assignment operators expand. We may do a double or equals. Sure, why not? That's pretty non-controversial. It's also kind of low priority. But default parameters are really what people use double or equals for, or this short-circuiting or, because it preserves the value, like in Perl, like in Lisp, unlike in C. The falsiness of Baz would cause the default value 42 to be used. If Baz is truthy, though, its original value, whatever it is, could be 100, could be a string, not the empty string, is used. And so people really want they want to have a default parameter value in case not enough actual parameters are passed. And the defaults evaluate left to right, so you can actually use the earlier parameters in later default values, which is what you want, I think. And that's cool. REST parameters, this is like death to arguments. Arguments, by the way, arguments is not just, I think, clunky and confusing for programmers. It's a real pain for implementers. I think if you got like V8 and JavaScript Core and Trace Monkey people together, we all like get really drunk and just bust on arguments. And one of the weird things about arguments is that arguments of 0, and if you have a function taking parameter x, they're aliased. So you can't tell if someone's clobbering x through arguments of 0. You sort of have to assume this. And you may not see arguments of 0. You may see arguments sub I, where I is some value you can't really evaluate at compile time. So arguments just suck. But if you use this ... syntax, again, new syntax, it's coming, you create a rest parameter, and what you get is a real array, which you can slice and all that other stuff. And there's an operator form of this, ... prefix. It's a unary prefix operator. It's usable only in certain contexts. It is, I think, called spread in Common Lisp. Common Lisp had everything. It's like Steve Yegi said, Common Lisp, he said, what was it? Scheme is the Ferrari, very fast, no heater, no radio. Emacs Lisp is the Subaru 1984 that's always in front of you. And Common Lisp is Howl's Moving Castle. Yegi's funny. And that's true. Common Lisp had everything. So we have this spread operator idea. If you have an array, or maybe even an array like something with a length property and these indexed elements up to that length, then ... in front of it in an argument list will expand the array elements as positional parameters. And this generalizes function.prototype.apply, so you can use it with any callable object. You can also use it with constructors, which was a real sore point when I was writing Narcissus, because I couldn't make a metacircular new operator because I had to call new with exactly the right number of arguments. So there's this ugly switch that expands to, oh, it's 1 argument, oh, it's 2, oh, it's 3. I gave up after 8 or something. But ... fixes this. And there's even some demand to put this into array initializers. So you could expand an array positionally inside a larger array that you're creating. That probably makes a lot of sense. And this will blow your mind. Put it inside object initializers. Does it really make sense? What are you doing? You're sucking out the enumerable own properties of the object on the right of ... and you're expanding them in place in the outer object initializer you're creating. That might work. It's something that Successor ML has. It's called row capture. So we're looking at that. But spread's pretty cool. And spread and rest are going to kill arguments some fine year. I'm patient. Now, the way we work in the committee is we have proposals, probably too many, but that's OK. And we call them straw. We can burn them up if they're bad. The ones that I went through have been promoted to Harmony, which means that they're pretty much going to be in the next standard. And the proxies thing I mentioned, which you can go look at, is also in that status. And we've actually prototyped the proxies proposal of Tom Van Cutsem and Mark Miller in SpiderMonkey. It hasn't shown up in a release of Firefox yet. But this stuff is not yet harmonious. It's on the radar. We'd like to get there. WebGL has done some crazy thing. Again, Common Lisp had it. It was, I forget what it's called. One of our old Lisp heads knew it. WebGL has a way of taking a buffer, could be binary data, and then making a dependent array that views it. It's fixed size buffer. The array that views it is viewing it as a sequence of machine integers of different sizes, uint8, uint16, uint32. And you can have several of these views. You can actually do type punning. You can look at it as 32-bit numbers or 16-bit numbers at the same time. We've implemented that in nightly Firefox builds, and we've got WebGL going with that. You guys have probably seen the demos here. So those may show up in the ECMA standard or something like them, because people need to stop hacking binary data in strings. Now, after Billy's talk, I don't know if people should be hacking binary data anyhow, but it's the tool's neutral. It's how it's used. So classes are still on the radar, and people shouldn't freak out because they're kind of low priority at this point. I mean, who here really needs class syntax in JavaScript? Don't be shy. Come on, be brave. Be cognitive dissident. It's OK. Classes are kind of like, if you had them to make better constructors that acted more like built-in constructors that can make objects that couldn't be tampered with. Maybe that'd be good, but maybe not, because you can already do a lot of that in ES5. You can do it in JS. Concurrency, I wrote a blog post about how threads suck, and we already have web workers, so I don't know what we need to do here. There's some interest in event loop concurrency. There's some interest in something that's really not concurrency, but rather control effects, continuations. So we're looking at this. It's a big area. And what we're not going to do is we're not going to put in shared mutable state that threads race over. We're not going to have synchronized blocks. It won't be just me whose dead body that has to happen over. The whole committee is pretty much in agreement there. This comes up because there have been real exploits of webmail, like the MIME separators in some webmail implementations get computed on the client using math.random, which is this piece of shit I copied from Java in 1995. And it's really bad, so we're going to look into adding some random bit generator that's actually strong. Not sure what it'll be. Your advice is welcome. Generators and iterators are still on the radar. I did this thing based on Python. We cleaned up a few edge cases to do with generator exit, and we're trying to rationalize that with all this continuation research. We'll see how that works out, but iteration is important. The for-in loop is kind of broken and weird and doesn't work the same for all kinds of objects across browsers, so if we can fix it, we ought to also make it meta-programmable so you can write your own iterators so you don't have to just go over the properties of an object, and in particular, you don't have to have, like the proxies proposal, reflect everything eagerly. Like if you have a billion properties, why would you want to make an array of a billion properties? You wouldn't. You'd want to have some lazy iterator approach. So we're going to do that. Expression closures. This is fun because we implemented this and we did it in a way that has a little grammatical error in it, which Waldemar Horwath of Google caught. It probably can be fixed by grammar factoring, a little more parenthesization for some kinds of expressions. But it gets rid of curly braces and the return. It doesn't get rid of the big fat function. 8 letters, man. I was influenced by Eich. So here you go. This is a poll. I did this at the YUIConf. It was informative. Somebody on the ES discuss list wanted backslash because it kind of looks like a lambda where your typewriter's broken. And but it's crazy because it also is like /u for Unicode identifier characters. So I don't think that works. But what do people think of backslash? Thumbs down. How about Greek lambda? Can you type it on your Mac keyboard? You cannot. It's also backwards incompatible change. ES3 allowed Unicode identifiers, including lambda. Yeah. We can still take it. Doug likes this one, the florin. This you can do on your Mac. Compose F. All right, that's florin's winning. And then somebody at YUIConf reminded me that I didn't actually poll people on none of the above. Oh, clap. You got to clap. You aren't competing with the last one. Yeah. We'll see. Fun. New keywords. Yeah, maybe. How about FN? SML.
LOL.
How about a function isn't too long?
/VE.
We're not, yeah, that would be good. We're not going to get rid of function. So one of the things I should say is that we're not looking to change the language in big ways. With the web, you have to put out fresh carrots to lead the horses away from the rotting vegetables so they don't get really sick and die. And then someday they actually do walk away, and then you can sweep up the rotting stuff. And that's going to take years. So we're mainly adding, and we're doing things like strict mode so that you can, if you opt into strict mode, you get rid of some stuff faster. You're a smart horse. Lexical scope, the global object being the top scope object is just a huge nightmare. And it's bad for implementations, it's bad for security, it's bad for people sharing, developers trying to share code. So we're going to have lexical scope one way or another. And I'm going to talk about module systems because those, if you get them, will have lexical scope, nothing but, all the way up. You'll still be able to get the window object through some named reference or some this binding. We've looked at modules, thanks to Chris and others. We've looked at the CommonJS stuff, and we've got a proposal called simple modules that I may talk about. This one's fun. There's an old Lisp idea of the symbol as something that's first class, something that you can use when you evaluate an S expression, but you can also compare and pass around. Common Lisp again went crazy and made symbols into things that could be in packages, very much like ES4 namespaces. Boo. So we're not going to do namespaces, but we might do names. We might do some way to have an object, let's call it, or some like unforgeable string. It doesn't really matter what it is, except that you cannot spell it through any string or string equivalent property name index. It would be not enumerable. It would be useful for sort of value capabilities, for keeping secrets with yourself and friends. You could pass these things around. There's lots of uses for these. You could even decorate the standard object prototypes, including object.prototype, with your own name object keyed properties. And you wouldn't collide with anybody. You wouldn't break anybody's for in loop. You wouldn't break any object detection code that was looking for a pre-existing property. So the name objects look good, and I think they'll get to harmony status if we just do the work. There's a bunch of object initializer extensions coming. We have the get and set stuff that we did at Mozilla 10 years ago, finally in ES5. There's an obvious thing you could do with Const if you wanted to make a non-writable, non-configurable binding, or to use the earlier language, a read-only, don't delete binding. Maybe there should be shorthand for doing methods. It's a little more controversial, because what is a method after all? Is it one of these Java things that you can't extract and pass around as a first-class function? That sucks. We want first-class functions. So anyway, there's a write-up on the wiki. And object initializers are cool because they're sort of pseudo-declarative, and if they're in the right phase of the moon, they actually are declarative, and you can optimize them that way. So we'd like to build on that. I don't know about this. The idea of runtime type guards is maybe more like a contract system in certain scheme dialects. At the edges of your module, you want your API to have some sanity checks that you don't have to write open-coded logic for, but maybe not. This was the big thing with ES4. People thought we were doing a static language like Java. We weren't. On the other hand, if you look at how ActionScript is used in the Flash player, and this is something that I do think Macromedia and then Adobe miscalculated on, you see people encouraged to annotate every variable. And I talked in 2007 in London about how if you annotate :int on your loop controls, you actually slow down your code. Because all the expressions using that I:'int variable are in JavaScript, which is ActionScript. They are evaluated as if they were IEEE double. You have to check for overflow. If the integer gets too big, it doesn't wrap around 32 bits like an unsafe C integer. It goes and gets into a wider 64-bit double. And so it's actually slower to annotate :int. Because it forces the 32-bit C semantics. So types are kind of a bogus thing. And I have another story about types. We have hired somebody at Mozilla who's a Stanford PhD working on static analysis. He's really good. And he just in the first 3 days wrote a static analysis for SpiderMonkey that on SunSpider takes 8 milliseconds and infers all the static types it can, which is almost all of them. So once we get that in our JIT, it's going to be super fast. That means you really don't need to annotate types if your code is well-written, latently typed, has stable types. If it doesn't, that's fine too. Value types, I'll say something about them in a minute. I have a story about this. IBM has been pushing to get decimal into ECMAScript by hook or by crook, and Croc talked about this. I think the rest of us in the committee were like, every time they bring it up, we're like, not again, give it a rest. Because for one thing, it really isn't in the hardware yet, and in hardware where it has been implemented, it's still slow, and it's not something that any browser vendor is going to implement. Also, nobody's going to switch the number type in JavaScript to decimal. It's just not going to happen. Not only is it too slow, it's incompatible at the edges. It would break the web in subtle ways. All these WebGL programs would hate it. But value types are our general idea for allowing you to add, let's say, new kinds of objects that are immutable that can be compared by value or memoized. They don't compare differently by reference. And they can overload operators, because that's very important for usability. Java really missed the boat on that one. There's a funny blog by Cameron Purdy where he talks about big decimal, big integer, big trouble, and how C# got it right by allowing you to use operators for its big decimal, but Java didn't. And the first blog comment is some guy working on Wall Street says, yeah, this is so true. In our Java code, we were doing code review, and we saw somebody using big decimal. And the first thing they did was they had big decimal A and big decimal B, and they wanted to add them. So they said A.double value plus B.double value. There goes the national debt. right out the window. So you need operators, and that's part of it. You need literals, too. And then versioning, I don't want to get into examples because it's kind of painful, but we'll see some in the module slides. Versioning is coming. Because of this new syntax, you're going to have to hide it from old browsers. You're going to have ways of switching it in and out if you want to use it. And if you just want to wait in 5 years or however long it takes, you can do that, too. And keep using ES whatever. And weak references. This is kind of long-haired stuff, but it avoids memory leaks. Has applications for tables where the index is an object. The key is an object. So let me talk about modules, because this was one of the things that I didn't have time for sure in the old days. Module systems are an ongoing area of academic research. And when I was in a hurry, I looked around and I saw, oh, OK, script tags, containers, script source equal. Yeah, I'll just use HTML for my module system. It's been a long time leaning on that. So we're looking at a simple module system. And here, Harmony means some RFC 4329 compliant MIME type. It's just a placeholder. But we're looking at second-class module systems. That means that these are, unless you do extra work to reflect them into runtime objects, these are static delineations of your code. These are a way for you to say that here's my pile of code, and it's got the inside that you shouldn't see and the outside you should use, and you can do the same. We can trade and not step on each other. And like I said earlier, when you start using this new syntax, especially if you start using this this new MIME type, you get I think that's what, thanks. I was checking all the possible sources. Nobody's calling it, but if you start using this, you're using lexical scope. There's no more global object cruding up your top level. So I think that's going to draw people to opt into this to the extent that they can. And this is a dumb example. Who wants pi with the wrong number of significant figures? But it shows how you can export things. It kind of dodges some bullets by having a second-class system. There's behind the scenes, there's obviously something that makes an instance of this for you. It's not up to you to make the instance of the module. It happens. It happens at compile time. And the way you use modules is by importing them. And it's important that that be syntax so that the compiler can see all the imports that are statically present and compute the dependencies and preload them. So you don't have places in the execution of that script where you go off blocking, waiting for something to load. That's going to violate the JavaScript execution model. It's going to allow for race conditions, nested event loops, bad things like that. So import has to be syntax. It has to be seen. And that's good for most cases. You do want to dynamically load modules. We'll get to that. And there's something clever here picked up from the destructuring case. When you want to import only a couple of names, you can put them in curly braces, just like the shorthand for object destructuring. That's going to pull sum and pi out of math and bind them to lexical, that is, let-style bindings in the current lexical scope named sum and pi. And there you see them being used. There's some argument about what you should do if you import everything. People don't like this, but it's very convenient when prototyping. I don't think we should try to mold programmers too much to one model or another. I don't think we should have too much bondage and discipline programming in JavaScript. So some people want to have an explicit braced star, meaning I know what I'm doing, give me everything, even though it could be an unbounded set of names or a name set that grows over time. Others just say import math, give it to me. You can also rename the module when you import it. And when you do that, now you do get a first-class reflection at runtime. You get an object denoted by M, and you can use it as an object. But there was still an import there that was seen by the compiler, and math was still found in some table. Some configuration mapping told us how to find math in your file system or on the web. That's a separate issue. We want to separate that from the language. That's not something we want to embed in the language. Though, as I'll show later, we may allow URLs, because, again, during prototyping, it's very convenient. Here's the classic name collision problem. So you have two notions of draw. You're trying to import them both. You want to rename. And it plays on the destructuring syntax. Here is a case where you can use a URL. Maybe it's a bad idea. I think we're going to have to hash this out in committee. I'm interested in people's opinions. Again, when you're prototyping, or maybe even when you've deployed, you might want to use this. You might not need to go through extra indirection, manage your configuration through some module loader configuration table. Why not? And there's even some ideas that you could use fragment identifiers to load one module from a larger URL that contains several modules. I'm not sure if that's a good idea, but there it is. This is all kind of straw man stuff, just to stimulate your thinking. You can have, if you're doing CommonJS, if you're doing JavaScript on the server side, you better have a file system module, and you'd want to use it. And you can use it here in a very pretty way, which is kind of cool. And this is something I think JavaScript has been really lacking for too long. It's been impoverished by this sort of browser environment that has been its standard library, and it's a really terrible standard library. So with a real module system, developers can start to build the true standard library. And I should say, the people on the ECMA TC39 committee do not aspire to design the standard library, right? I know the history of the C standard library. Mike Less wrote the version. It took like umpteen years. It was incredible pain. We don't want to do that. We want to give you the tools so that you can build standard libraries. They can compete and cooperate and do whatever they want in the web and in other embedding contexts on the server side. These are second-class modules, but they can handle cyclic dependencies where the import dependency graph can be seen. And here's the old odd and even semanticist's favorite inductive example. Recursion, mutual recursion across modules. And that should work. And then finally, of course, you do need to load code dynamically. Either you don't know that you need it up front, or it's too big and you don't want to load it all. So there'll be a request module with a callback. Again, preserves the execution model that we all know and hate, that makes for continuation passing style programming. Maybe the continuation work I mentioned earlier will take the sting out of that. We'll see. But there should be another way to do it, which is sort of give me a list of modules and do your best to find them. We think this might be important. This is, again, straw. Maybe this is overkill. But you'd have this array, and you'd go through it and try to get whatever comes first. And there also could be static module detection in the same style, using the same sort of patterning, which would use something the compiler could see, the import syntax. And there's other stuff. I'm going to go fast here. This is an example of how you can make modules that are parameterized by modules, so you can make things safer. You can have the DOM munger, and it has a make function that takes a DOM API, which would be a separate function. And this is all in the wiki. Yeah, HAL 9000. And then you put it all together. This is more like the capability, object capability style of programming. And it's possible to do it with a second-class system. You just have to write your own make functions. And you have to be careful not to violate the principle of least authority, which no one does. So finally, simple shared state example. This is taking advantage of the second-class nature of the modules. The system makes the instance for you, so there's one var counter. It can be incremented. It can be fetched. So my conclusions are still hopeful. I'm not the young Morrissey-faced optimist that I used to be. Or Vince Vaughn, please, Vince Vaughn. And neither is Vince, looking at him. But I'm still optimistic. I think things are going well. I think we're going to have a new standard out, the best one we can possibly make by 2013. And it's going to have a lot of this stuff in it. And before it's written in that standard, it's actually going to be in multiple browsers that you can test. Maybe nightly builds, maybe betas, who knows. Some of it's going to be so uncontroversial, it's probably going to ship. And that's fine, too. That's how the web makes progress. And it's better that it make progress with cooperation in the standards body than absenteeism by Microsoft or bitter conflicts like we used to have. So, one of the consequences of this harmony is that we don't overreach. We don't try to jam too much through the process, too big a pig through the Python. And we definitely try to follow what the W3C wants to follow and doesn't always do either, which is to prototype before you standardize. And that puts us in the reality-based community. Good for us. Any questions?
At the beginning of this conference, Douglas mentioned that he thought that the TC39's most important job is to solve cross-site scripting. Do you agree with that?
No. Let me talk about security. Security is not a separable concern. That's actually the title of a paper by Mark Miller and John Shapiro, who I knew at SGI, and others. And it talks about how something David Parnas has been talking about since the 70s. Security and modularity and motherhood and apple pie are constant, eternal vigilance struggles. And they, in particular, security is a set of end-to-end properties. These are, Fred Schneider at Cornell actually developed formal theory for this. They're safety properties. They're predicates over all future program states based on the current evolution of your program, however you trace your program execution. So you can prove that if you got here, nothing bad ever happens. That's a safety property. That can be enforced a number of ways. Unfortunately, we don't have many of them in the browser. We don't have memory safety in our implementation language. We all use C++. It's a nightmare. We don't have control flow integrity. People jack us all the time. They take over control flow. They do return-oriented programming. Away they go. This is the pwn-to-own story. Google Chrome has done the best against this simply by using process isolation with lowered writes. But even then, there's WebKit in that lowered writes process. WebKit's full of memory safety problems, control flow integrity problems. If those can be exploited to escalate privilege across the channel to the browser kernel, then you have a real exploit. It can happen, and I think it did after pwn-to-own 1. So we're looking at security as a long-term commitment to actually automating the enforcement of safety properties. Doug wants to stop the world and have us fix security. That doesn't work. Right? The world's not going to stop. As Dion said in his talk, first day, HTML5 is here. It's not going to be turned back. And you're not going to fix security, and then utopia is here, and we have 1,000 years of peace. Security is going to be an endless struggle. Dorothy Denning, who did some of the pioneering work in information flow security, got an award in the early 2000s, and it was an InfoSec award. She gave a speech. Some of my academic friends are dismayed by it, but I think it's realistic. It said, we were working in the 70s in our machine rooms with people at terminals, and we had this notion of a small network, and principles are people, and security could be solved through proofs, through theory. And look what happened. The web grew out, and all the stuff we hated, like patching and testing, was necessary to fight viruses. I mean, it sucks. It doesn't really work because you're always in an arms race, but if you didn't have that, you'd really be toast. So she said, thank God for patching and testing. All our theory has been kind of not as good as we'd hoped. And it comes down to the problem with large systems is kind of like Gödel's incompleteness theorem. You cannot use theory or perfect coding because Murphy was an optimist. Shit happens. And one of the things that I like about the object capability guys is that they do try to minimize authority. They do try to get people to use true modularity, to build their systems in small pieces they can reason about. But I've seen this time and again. People leak capabilities unintentionally. They build large systems and they lose sight of it. And that means you shouldn't be relying on people. We are not going to be Amish coders building very nice little wagons. We're building fucking jumbo jets and nuclear power plants. And if we're doing them with Amish coding techniques, they're going to blow up. So I don't agree with Douglas. What we need is automation. We need Skynet, benign Skynet. We need, I mean, with the hot robot from the TV show they canceled, River Tam. But we need to use the pieces of code that we trust the most, the compiler and the VM, not even the operating system. Those things are huge gas bags of crap. The compiler and the VM can actually cooperate to enforce a lot of these properties. And that's what we're working on at Mozilla, and that's a long-term project. And that's not something I would try to prematurely standardize. Cross-site scripting, I created script source equal in Netscape 3. I didn't make 2. And like image, source equal, and other things, it can go cross-site. So you can pound include code into your trusted computing base, and it can totally jack you. Like everybody knows the pro.com story. They were using some stupid advertiser who lapsed their domain registration, and a porn site grabbed it and stuck a bogus ad that set window.location to porn.com, and Larry Wall fell over. And why should the advertisements that you inject with script source equal have the same rights as your own code? Why should they be able to read cookies or form elements? They shouldn't. So we're going to actually experiment with this. We're going to break the web a little bit. We're going to change the way that code gets labeled and objects get labeled in JavaScript so that you're always labeling. This is something that Adam Barth at UC Berkeley advocates and Leo Marovich at Berkeley. Always label everything and don't lose track of stuff. Like, oh, was that object from me or from scumbagadvertiser.org? I don't know. We're going to keep track of these things so we can then have better default integrity policies, access control policies. And I haven't been able to do the work to report on this. I talked about this last year at W2SP, but we're going to get to it probably this summer, and we'll see how it goes. The web needs to be broken a little bit. I mean, I don't know if I'll break Google Analytics, but I don't really care. I want to prevent those advertisements that are injected cross-site that just do some stupid flyover from reading your, your form, reading your credit card, reading your cookie. And I think we could probably get away with that. So that will help cross-site. There's easy things we can do. I don't mean to say we have to do this long VM compiler thing only. We should look at security all the time as part of our job. And that's really the lesson of security not being a separable concern. But that means we don't stop and fix security first before we do anything else. Any more questions?
So traditionally, lots of the kind of newer stuff has happened in server-side JavaScript. So obviously, if you look at SpiderMonkey or Rhino or a bunch of those that run in JavaScript 1.8, which is diverged from ES5, right? There's a divergence there. With especially server-side JavaScript becoming a lot more popular, how do we bring those things back together so that people have a really similar JavaScript, ECMAScript environments on both the client and the server?
And how do we allow incremental improvement?
Well, so divergence is hard to bring back together, but everything we've done in JS 1.8 is either in Harmony or on the proposals page, or we're probably going to yank it. So we're trying to hew to the standard. We're not trying to do our own brand X. But it's going to take time. Rhino, thanks to Steve Yegi and Norris Boyd and others at Google, has tracked us. I've talked to the Apple guys, but they're kind of, they want to stick to the standard, and they want to be as fast as V8, and God bless them, they've done a good job. So I don't know if they'll be the ones to join next, but as this stuff moves through the Harmony process and becomes harmonious and becomes well-specified, I would hope it would get implemented by more than just the Mozilla implementations. And that's part of our covenant in the committee, that people will implement prototype standards with prototype code and test it. So I would expect Microsoft would do some of this. You'll see destructuring in some Microsoft build. You won't get open source, but you'll get a DLO. That could happen. That's the best I got, sorry. Questions?
Can I just say thank you for making an awesome language?
Oh, you're welcome. I'm getting verklempt. One more thing I forgot to show. This is something that the IBM guy sent me. He wanted me to rub Doug's nose in this, but it's not Doug's fault. But there it is, Yahoo Finance, April 15th, 2010. IEEE double, bad rounding. Right there, in your face. It's really Yahoo's fault. Google, I'm told, uses only integer arithmetic for its JavaScript, big num stuff, and gets it right. So, but yeah, it's kind of a coding burden. There it is. We do need to fix this. We can't just change the decimal. We'll see what we can do. I have one more thing I wanted to show. This is kind of long-haired, but and this is kind of a sneak peek too. We got tired of, after TraceMonkey took off, we were competitive for about like a week, and then V8 and JavaScript Core started going crazy on each other, just optimizing for their respective benchmarks. And you can see this because they're both really fast. But look who's faster on SunSpider, Apple Nitro. And look who's faster on V8. But by a nose, right? And V8 is the weirdest series of benchmarks. You should run JSLint on it sometime for entertainment, or JSHint if you want to be treated nicely. And SunSpider's got some bogosities, but it's better. So we've been working on JagerMonkey, and you can see that we're getting faster. And I think by the time I speak in London in June, we're going to actually be down there with the Bobbsey twins. And we might even get faster because tracing does give us greater type specialization. We can go, our tight inner loops for numerical loops can be down to the metal, no speculation. It's all hoisted out of the runtime by compile time. But talk is cheap. We'll see how that goes. That's good news. I don't have Opera here because the guys who did this used a Mac. Opera's done a really great job. This is also a sneak peek. This is from an academic friend of ours. What he's done is he and his grad students have plotted the slowdown you get if during a certain number of loops you have an optimization fault, which we know about from tracing, but it happens in all the browsers. You get some kind of pathological thing that your speculation doesn't work on. And on the left, on the x-axis, it's where the optimization fault happens every time. And on the right, it's where it happens 1 in a million or something. And what you'd like to see is a straight line at 1, a constant 1 function. And sure enough, Firefox 3, which didn't have JIT, was my caching interpreter, is nice and flat. It wasn't particularly fast now. It was fast for its day. But it doesn't have this problem that it gets unstable with optimization faults. It doesn't really slow down or become unpredictable. 3.5 is when we introduced tracing. It's kind of not flat. And there's some particular instabilities on the right there. 3.6 is getting better. I did some work that made this a lot better. And 3.7, even better, down where it should be. That's nearly 1. The scale's off by, there's a weird outlier that threw the scale off. You can see a red dot real high. Chrome is not that predictable, surprisingly. Opera, good job, really flat, totally predictable performance, even though there's optimization faults being injected, either every loop, every other loop, every 1 in 10,000. On the right, they have some problems, but on the first 2 benchmarks, they're doing great. These benchmarks are a little not representative, but they do try to inject faults. And then Safari's kind of curvy, but a little flat, and then the right one is a torture test. So this is like cutting-edge research on how to make JITs pay off and not bite back. And I wanted to show this because it shows, really, we're all doing good work, good for us. We're all making JavaScript insanely fast. If you go back a few years, it was just like an order of magnitude decimal slower, 20 times slower, and it's going to keep getting faster. So that plus this static type analysis I mentioned, this type inference, I think JavaScript's got a long road ahead of it. It's not going to max out, and you're going to need to reach for native code very much. Maybe if you're programming a DSP or a GPU, but maybe not. We'll see. So that's good news. And yeah, are we fast yet? No, but we're getting there. Sorry, any more questions? I'm over time. Thanks.